Okay guys, so a lot of people have requested notes and I've had a lot of people sick because of the flu and things like that. So I'm gonna go ahead and go through these notes just in case we need a little refresher or if you've missed. So similar figures, figures that have the same shape, but not necessarily the same size. Those are called similar figures. And you'll see this sign, a little symbol that represents that, and it looks like this. If two polygons are similar, then their corresponding angles are congruent, which means same size, same shape. And the ratios of their corresponding side lengths are equivalent, equal. So determine whether triangle ABC is similar to triangle DEF and explain. So it kind of goes through and it walks you through step by step each of these side lengths, and it says yes, A is similar to D, B is similar to E, C is similar to F, and it works through their ratios and all those things. So I'll show you what that kind of means, and then we'll go through a quick way to see if they're proportional. So when you're given triangles especially, and they have these little half circles on the angles, what you can do is you can go through and you can label them. So there's one little half circle on this, so that's angle 1. There's 2 on this guy, so we're gonna call it angle 2. There's 3, so we're gonna call it angle 3. Same thing over here, 1, 2, and 3. So then to see which sides are corresponding, all we have to do is look and see. Well, A and B is between angle 1 and 2, so that's 4. So then we can come over to our bigger triangle and look and see, well, what's between angle 1 and 2 over here, and it's 6. So then if we were gonna write that in a ratio, we would write 4/6. Okay, I always think it's easier to go left to right. So then you keep that pattern up. You go left to right to get your other ratio to make a proportion. So then we can pick one more side. I'm gonna pick angles 2 and 3, or between B and C, just because it's a smaller number. So between angle 2 and 3, between B and C. So let's look at our bigger triangle and see what the side length is between angles 2 and 3 over here. It's gonna be 9. So I would write that ratio 6/9. Okay? So then to see if they're proportional, a lot of times if you can set up this proportion, and then just like if we were gonna solve for a missing side, we can cross multiply. So if I multiply 6 times 6, that gives me 36. If I multiply 9 times 4, that also gives me 36. So then that just tells me, yes, they are proportional. Things are great. So then let's look at our second example. It says rectangle KLMN is similar to rectangle PQRS. Determine the missing side measure. So, and one reason they do that, they give it to you KLMN, is so you know that these are in the same order. K is corresponding to P, L to Q, M to R, N to S. So the corresponding angles are congruent and the ratios of their corresponding side lengths are equivalent. So we need to write a proportion. It works it out for you, but we'll kind of zoom in and work it out over here. So I need to set a proportion and I'm solving for X. That's my main goal. So just to see, we can start with side length of 4, so between K and N. So when you've got a rectangle, remember that this side and this side, those are the same. Those are my widths. So my widths are always the same. So I need to find the corresponding side on my smaller rectangle, which would be 3 in this guy. So I'm going left to right, in this case, big to small. So I'm gonna write 4 to 3. So then my next side length, K to L, is corresponding with my X. So I'm gonna write 5/X. So then we need to cross multiply. So 3 times 5 is 15. 4 times X we write as 4X. So 4X equals 15. Then I just have to divide to get rid of that 4. So I have X left. So then 15 divided by 4. 4 can go into 15 3 times. minus 12, that gives me 3. I'm going to add a decimal. Bring that down. 4 can go into 37 times, so 28. I'm left with 2, add a 0. 4 can go into 25 times. So my missing side length is 3.75. Okay, let's look at some of these example problems. Determine whether rectangle ABCD is similar to rectangle WXYZ. So again, it tells you in order, A and W are the same, B and X are the same, C and Y, and then D and Z. We're deciding if it's similar. So we're doing like we did on the first example where we're gonna make our proportion, cross multiply, see if we get the same numbers. Okay, so first thing, let's start with 12. That's our length. Okay, so we need to find the corresponding side on our sideways rectangle. So our length on our sideways rectangle, so that's gonna be between W and X, 9.6. Again, left to right, so I'm gonna do 12 first. So 12 over 9.6, and then I need another ratio so I can make a proportion. So I'm gonna use my width, my shorter side. So A to D, 5 over W to Z, 4. I wanna, got confused. Then we're gonna cross multiply, so 9.6 times 5. 6 times 5 is 30. 9 times 5 is 45, 46, 47, 48. And then I want to divide, nope, we're not dividing. Sorry, y'all, I keep thinking I'm looking for a missing side. Okay, so that's 48, and then 12 times 4 is also 48. So that means we can write similar off to the side, or yes, or a big check mark. They're proportional. Number 2, let's get rid of some of this. Okay, the triangle below are similar. Determine the missing side measure. So in this case is X. So we can go left to right. So if I go left to right, I can pick 6, which is between angle 1 and 2. So what's between angle 1 and 2 on my smaller triangle? 4. So I'm gonna go 6 to 4. And then that X value, it's between 2 and 3. 2 and 3 over here would be 15. So again, since I went 6 to 4, I went left to right, I've gotta go left to right again. So 15 over X. So we cross multiply. 4 times 15, 5 times 4 is 20, 4 times 1 is 4, 5, 6. And then I want to divide by 6. So 60 divided by 6 gives me 10. So that's my missing side measure. Okay, the next page. So determine whether each polygon is similar, explain. Okay, so we want to see, we can start with this side. I'll start with my length over here. So B to A is my length, it's 10. So the corresponding side on my larger rectangle, it's still the length, so that's going to be my corresponding side. So I can write that as 10 over 15. So then I'm looking for the next ratio. I'm going to go back to my left side, left to right, left to right. So 8 between A and D is congruent or corresponding with E to H, 12. So I'm going to write 8 over 12. So we cross multiply, see if they're the same. So 15 times 8. So 120. Let's see, 12 times 10 is also 120. So they're proportional, yay. Or similar. They're the same, yay. Okay, number 4. This is where the labeling your angles comes in mighty handy because look at this mess. Okay, so on our bigger trapezoid, we've got one little half circle here, so I'm going to put a 1. I've got 2 here, I'm going to put a 2, 3, and then 4. And then I'm going to come over here, this one's on its upside down. So 1, 2, 3, 4. Okay, so it doesn't really matter which sides we pick because they're going to be, if it's proportional, it doesn't matter which side we pick, it'll be the same. So I'm going to start with between angle 1 and 2, this 15. So I'm going to look at my other trapezoid. What's between 1 and 2 over here? 5. So 15 over 5. Go left to right. Okay, so then I'm going to pick one more, and I like 24 because it doesn't have a decimal, and that's between angle 1 and 4. So let's look over here between angle 1 and 4, and that's 8. So 45 over 8. So we cross multiply. So 15 times 8, that gives me 40, 120. And then 45 times 5. So 225. So are they similar? No, we got completely different answers here. So not similar. Okay, last two each pair of polygons is similar. Determine the missing side measure. So on this one, we're looking for that missing side measure. So again, we want to use our labeling of angles skills that we've learned because that's super helpful because look at how crazy these look. So I've got angle 1, 2, 3, and 4. And on my bigger image, I've got 1, 2, 3, 4. So let's set up these proportions. I'm going to pick, well, we're solving the missing side, so we kind of have to pick this side of x, which is between 3 and 4. So let's look at our bigger image. What's between 3 and 4 over here? 18. So left to right, I'm going to do x over 18. And then I'm going to pick one more just so I can set up a proportion so I can solve for this. So let's pick, I'm going to say between angle 1 and 2, since it's a small number, 3. So let's look at our bigger image. Between 1 and 2 over here is 6. So 3 over 6. So let's cross multiply. 18 times 3 is 24. So that gives me 54. And then 6 times x just gives me 6x. So 54 divided by 6. That is 9, so x equals 9. Last one, number 6. One more time, we gotta label these. So 1, 2 rings, 3 rings. 1 ring, 2 ring, 3 rings. Okay, so again, we're solving for x, so kind of forced into using this side since it's x. I'm gonna go left to right. So my x over here is between angle 1 and 3, so what's between angle 1 and 3 on this side? 8. So x over 8 equals, and then I'm gonna pick another number. How about between 3 and 2? Pretty little 5, so between 3 and 2 on this side, and that's 20. Sorry, coloring skills are not good. So 5 over 20. And then we want to cross multiply. 8 times 5 is 40. 20 times x gives me 20x. And then I just have to divide. Cross multiply and divide. So x equals 2. And that's about it.